Thank you, everyone. So I will try to make it short so that we are on time, because it looks like we are going to be over time. But I'll try to make it short. So I won't go into a lot of details. Mainly, I want to talk about something that, well, first, thank you to all the presenters, because you guys have been giving a lot of different points, a lot of different information about what makes the whole ecosystem in robotics, especially on ROS here in Singapore and in the region as well. But it's also international views as well, get it? And that's fantastic. But I want to talk about something that is very important, which is about the education, and it's about how we bring the engineers into this area. First, let me just introduce quickly Singapore Polytechnic. So we are the first poly established here in 1954, and we have more than 13,000 full-time and part-time students. We have 30 full-time courses in there, and we have, on the School of Triple E, we have 10 collaboration labs. In these collaboration labs, we basically engage companies, and we develop projects together with them for different purposes. For us, of course, it's important to serve the industries, as well as to give opportunities to our students to learn in real projects. And I think that is exactly where I want to come into this picture. We've been working with robots, different type of robots. You can see here we've been working with mobile robots, humanoid robots, service robotics as well, industrial robotics. And we have a group of about 15 staff, multidisciplinary group, where we have people from mechanical, we have people from electrical, electronic engineering, computer science, working on these robots. But one of the things that I wanted to emphasize is why? Why do we need engineers? And I think it's interesting. I want you guys to look at this graph in here. Dr. Chan presented some slides, but I want to bring this one. This one is from 2015 in there. And the important thing of this graph, which I always, people find it fascinating, is that Singapore, we always refer to Singapore as a small dot. And if you look at Singapore, where it's located, it's actually here. It's not such a small dot in this map. And what this map is telling you, is telling you that a worker here in Singapore, in his lifetime working here, is going to have chance to see robots compared to somebody in Iran or India, where you have only like 2 robots in there. Those guys, they might work their entire life and they have never seen a robot. But like I mentioned, this is 2015. I wanted to now show you that one. It says that now we have about 6 robots per 100 workers, and that means we went for about almost 4 robots per 100 workers to now 6 robots. So that means it has increased in there. But one of the things that I want to emphasize in here is that, yes, we talk about these, and we also know the challenges for the future. We know that the population, not only here in Singapore, because we also hear that in other countries, we know that in Europe, you know, this is also a big problem, okay? There's going to be a shortage of people. But how to deal with it? Yes, we are all listening here, and probably this is also a little bit dangerous, because it might be like an echo chamber, where we always say, robot is going to help on solving this problem. Yes, but one of the things that I do want to emphasize is who's going to be the engineers that are going to be dealing with these robots. And I think this is an important thing. And I do want to say, why is this important? Because here, me working in the education sector, I've been firsthand looking at people that come on the engineering domain, and once they finish their diploma, they don't continue on engineering. They move to another domains. And this is a big problem, because I do have requests from companies sending me emails saying, hey, please, send me your graduate students. We want to hire them. We want to engage them. We want to hire them. We want to maybe for internship or all these things. But then the problem comes that these guys are not interested. So we've been thinking that an engineer should be fearless. And we've been thinking, how do we create a fearless engineer? And a fearless engineer, for us, the vision of a fearless engineer should be an engineer that is not afraid to try new things. Yes, and I think this sounds like a logic, but it also is actually difficult to achieve, because we have noticed that most of the engineers don't want to be working on something challenging because they are afraid to fail. And I do want to emphasize this. They are afraid to fail. And as an engineer, you should not be afraid to fail, because failure is final when you stop. For us in engineering, we always do prototyping, right? We come back, okay, didn't work, then pick it again and try it again. And it should be coming back in here. So this is what we try to infuse in our students, the Polytechnic in there. First, I do want to mention about the CCAs. CCAs in secondary and primary schools, they are doing a good job to attract some potential students into engineering, which is good. So we also have a lot of students that they're showing interest into these things, but sometimes we feel like when they come into the higher learning education system, they lose that drive. That is not something that we want, right? So we feel that those CCAs are good in attracting the potential engineers, but we feel that we also need to have more challenging projects of robots in there, and also to build up on success for the inspiration, the motivation, you know, to building the passion in these guys, so that they say, yes, I want to continue in engineering. So I want to tell you, before we start using ROS, it was challenging for us to build big projects. Yes, we drive these big projects, but one of the main things that we face is if you change hardware, because maybe this hardware already is spoiled or obsolete or whatever happens with this hardware, and you cannot get the same hardware, you need to buy another one. Sometimes the entire program didn't work. But now with ROS, it's a different thing. Now, and this is a beautiful thing, because now we know that with ROS, you just need to run a different node. Boom, that's it, end of the story, finished. Yes. Your work that you have to do in order to make it work is less in there. So this allows for a fast development of projects, but also it allows for building on top of existing projects. And I think this is the important key that we have in here. Why? Because in the past, when we used to work with robotics projects before we used ROS, our projects used to be small, because the students are usually with us for only like 6 months doing the project. And so it's a small project. And it was hard to pass it to the next group, and so the next group pick up and all these things. So it was very slow, the process. But now with ROS, we feel that, you know, the development is faster. And sometimes the students, when they're coming, they are actually excited because they know that it's a big project and they wanted to contribute into these things. So now I wanted to show you some of the projects that we have in the Polytechnic there that we did through a period. We actually started the use of ROS somewhere around there, about 2012. Yes. Before that, we didn't use ROS. So that was about this is ROS-I. Yes, we've been also trying ROS-II here. But one of the things that I wanted to mention here is this: we use different distros. In there you can see that we use different distros. Some of them, if you use them, you remember that they have good things, bad things, and there were some issues with some of them, that projects were not, certain nodes were not done, completed, so we needed to upgrade, and so on and so forth. But it was nice. So I'm going to talk about some of these projects, what they bring into for us, and how they help us to build an ecosystem of ROS in there. Now, please keep in mind that the robotics projects that we have in the Polytechnic, not everything is in ROS. We also have some other projects that are mainly on operation, deployment on other parts, but not only on ROS, okay? But these ones are mainly on ROS. So one of the first projects where we start introducing ROS was this robot, which is basically it's just the torso of the robot. And the idea is to be a receptionist. So we can put it, let's say the reception, you come to this event, you put it in the reception, and the guy is able to interact with you. And the main thing that we were having here is using the Kinect to detect the person, and also to, we were doing some face recognition in there, very basic with OpenCV and all these things. But when we tried this one here, so we were not very familiar with ROS, so we feel that ROS was very hard at the beginning when we started with this project. So I remember the students and the staff was also working on this one, remember that they were mentioning it was very difficult for them because they were not so familiar on how this ROS was working, okay? So what they were doing is that they were trying to create one single program for everything. But if you know, it should not be like that. The ROS model is mainly to have different nodes, and then the communication between the nodes is what is going to give you that emerging behavior that you're looking forward. But we did learn from there a lot, and I have a small video just to show you some of the features that we got with these robots. For this robot, we developed our inverse kinematics by ourselves, and after that, 2 years after, when we learned about Move It, so we actually tried with Move It as well. So that was also nice to see, because the students, they were learning with ROS, and this project ended up for about almost 3 years, 2.5, almost 3 years. So the students, they keep doing progression in there, and a lot of things that they were doing is, we have this computer here, and we were sending signals to the ROS system in there to start or stop or do certain things in there, and then after that, we left the interaction also do those things instead of just sending the signals from the computer. So we were learning how to do more modular programs as well when we did this one. Okay, so just show you very quickly that the robot dancing. So we did some dancing as well. At that time, there was this Gundam style, so the robot tried to do the Gundam style. But this is exactly what I'm talking about, because the students were excited. They say, I want to try the Gundam style. Yes, which is good. Come, try things, you know. Let them go crazy, because this is the time that they should go crazy, because they develop that passion. Yes, so then we have another project in here. So this is similar in the concept that we also have a social robot. The top is similar to the previous one, except that we also have a mobile base in here. So with this one, of course, we did more on the ROS navigation stack. So we learned more about how to create different modules. And this was a large project, and it was a multidisciplinary project where we were having people from mechanical, computer engineering as well, and electrical electronic engineering, and they were developing different things. There were different nodes, and this project stretches for about 2 years, almost 3 years as well. And in this project, the students managed to create different nodes, and then some of the nodes, they needed to be upgraded. And when we also used with a few versions of ROS, 2 distros of ROS, so which was also quite an interesting thing, because we moved from one distro to the other distro. We thought that it would be like straightforward, but we find out it wasn't that straightforward. So that is also something that we learned, but it was nice. And it was also a lot of fun for the students, because they were exploring things, and we were having interaction also when we presented the robot in there. So the next project I wanted to show you is, from that one we learned, of course, about the navigation, and then we came to develop a freight returning robot. And this one we developed it together with for the National Environment Agency, because they were asking for, hey, is it possible to explore some of these trolleys? So we explored it, and we tested in our campus facilities there, and it was nice. They saw it, they liked it, we collected the data for them and everything, but they told us, yeah, but we're not going to deploy it because they wanted to deploy it in hawker centers, like the Newton, which you know is not entirely flat. So for foreigners, probably you might not know, but Foucault is not entirely flat. So that was a bit of a challenge in there, but it was good for us because the students were very happy, and this robot was actually moving around the campus, and it also keep on fostering the rapport between the juniors and the seniors. The seniors were very proud to say, hey, this is my robot and these things, and the juniors were like, oh, can I join your group? Can I try next year? And so on and so forth. And it was quite nice. So we extended for about 2 semesters, and we get a very nice number of people that actually signed for this project, which was fantastic. We love it. And it was fast to do because it's just navigation. So it's a navigation stack. So we just adapted most of the things from the Turtlebot navigation stack. Then we also did this one in here, where this is we call it automated delivery system for handling lab samples in a hospital environment. And basically what it does is we have also mobile base, and then we get these to move from one station in the hospital to another station. And the students, the thing about this one is it's very similar to the previous one, but with this one, the students were excited because when we were going to the hospital, they wanted to be there. The students, all of them, they were very happy. They wanted to show the project, and a lot of people still also turn up for this one in here. The next one I wanted to show, which it was one of the stars, is this one. It really attracts a lot of people. And why? Because we learn with the other two, yeah, we can do navigation and all these things, but we also learn about the interaction. We like those social robots in the past. And what they did is they put this little screen in here, and it gives some interaction in there. So let me just show you a video. So this just got there, it's just some details. So let's see the video there. And it was just very simple, but what the students did is they don't just stay with the navigation stack, but they went a little bit more on doing the ROS bridge, the web bridge, and they created an interface, and they were able to load it on the phone, as well as to load it on their computer in there, control the robot and all for services. And we actually deployed the robot there in our school office for EEE. And that robot was running there for a couple of years until it actually broke down, so have to put it in the museum in there. But it's an interesting robot in there, and it was a very simple concept in there. So we were very happy. And the students from this project, these guys, they're actually finishing their university now, and they are gonna start the spin-off company on robotics. Yes. So I met them, and they told me that. And that's fantastic. Yes. The lady here, she already has a job. Yes. And still in robotics, which is good. Fantastic. Continue. That's what we want, right? They were very happy on developing those things, and now they continue in the area of robotics. So we also developed some other projects. So this one was with IMDA. Yeah, and it's basically to automate the utensil trolley that the aunties have to push from one side of a food court to another side where they can do the washing of these utensils. And it was not so challenging for us, but what we find out in this one, it was not so challenging in the sense that it was just the mapping in there, but what we find out in there is that it's actually quite challenging to deal with a lot of humans moving. Yes, with a lot of humans moving. And if you look carefully, even robots nowadays in the airport and shopping malls and all these things, our robots look clumsy. And I think this is also a challenge that I want to send back to you and also to bring back to me. We need to make our robots a little bit more smart, when they move. Very clumsy, like when there's a lot of people. How to deal with those situations? It's just a question on the floor there. Yeah. So the other project I want to show you, which is still running, and this one attracts a lot of students, is the driverless car. Well, we call it driverless car. Yes. And basically we started with this, a mobility scooter in there, and we started with this, and now we have this. Yes. We have a buggy there, but as you guys will see there, we're using ROS in this one. I let my colleague to do the talking.
Outfitted with the GPS, a lighter navigation systems, and wide range of sensors, and 5G wireless communication technology, our very first autonomous surveillance vehicle is being developed in Singapore Polytechnic by a team of Year 3 project students and dedicated lecturers. The vehicle is designed to sense its environment and navigate safely without human input. Passengers can book a ride on our autonomous vehicle via mobile applications on their handphones and enjoy secure transactions through a digital cryptocurrency payment options using a blockchain network. The autonomous vehicle is also equipped with the condition monitoring systems using server-embedded sensors to ensure that it is operating at optimum conditions.
So you can use it with, not with Bitcoin, with another currencies in there. So that's an interesting thing. But that is a crazy thing that the students started, and it's also attracting people that was purely on the computer engineering, and now they're coming and they start also getting involved into robotics. And they're finding their flavor as well. They say, oh, interesting. Oh, okay, come in, welcome. Everyone is welcome, because this is a multidisciplinary area, right? So the next project I want to present to you quickly here is also a delivery robot. So we have this delivery robot. Just show you the video there.
Big organizations, especially those with multiple departments like production, warehouse, and so on, tend to have more than one building within their premises.
Traditionally, the delivery can be done physically by human, but due to the current pandemic, the physical contact between humans should be reduced or even avoided. The SP delivery robot to the rescue. It is an autonomous mobile robot AMR that is capable of operating in an outdoor environment. The AMR can carry a payload of up to 10 kg at a maximum speed of 0.5 meters per second for items with the size of an A3 size paper. It can map its surrounding, navigate, and return to its source position autonomously. It does this by using high-resolution LiDAR sensors. The most important features of the AMR are able to operate on roads, uneven terrain, slopes, and narrow hallways.
So one of the things about these two projects that I just presented to you, they started with very simple commercial robots or with simple base that we adapted into robots. But one of the things that I wanted to say is this: these projects grew. So now, for example, for the one that I just presented, now we have a robot that we, together with the School of Mechanical, we developed, because their expertise is on the mechanical side, right? So they developed the hardware base. The computer engineering, they working on the program, electrical electronics, developing the control, and so on and so forth. So they are developing those things, as well as we using, you saw there is a Pioneer robot. So, and we using some Western robot in there. So we have different bases, and we have big groups in there of students now working on these ones. The last project I want to talk is probably the project that from which we have learned a lot in ROS, and we have also contributed a lot of ROS into the community, is the RoboCup competition. For this RoboCup competition, well, I'll show you the video, so it's much faster in case that you guys are not familiar with RoboCup. So the first part of the video is about the competition. This competition is similar to an industrial setup, where a robot has to go from one station to different stations, picking objects and placing objects in those stations. The height of the stations is random. So it's not, the robot doesn't know what's the height of the station in there, so it needs to deal with that situation. And then the navigation, the map always changes. It's allowed to put obstacles along the way, the navigation, so that the robot needs to be able to calibrate the route in there and go to another location, find the other location in there. The other thing as well is the identification of the objects. So it's also allowed to put defaults, so the robot needs to be able to find out what is the correct object that they need to find out. One of the things that we love of this project is that we take our students internationally. So this is in Thailand, just this year, early this year, in July, we took our students there, and they love it. Okay, there were not many teams as before, of course, because of COVID restriction, and at that time China was also closed, so not a lot of teams were there, but the students love the experience, and the students love to collaborate with people from other countries, from other universities, and to learn from them. Yes, because that is a very important thing for the students. So the students are always coming and they say, hey, we want to participate into these things. I let my student here. I want you guys to hear some of these comments.
Although my team faced many challenges along the way, we still managed to work together as a team and did the best we can with whatever we can. I also learned a lot this RoboCup competition by looking at how other teams work, and they were very professional. So it's a very good learning experience.
My experience with RoboCup 2022 is very interesting, and because I get to see many different weeks of the RoboCup tests, and also get to see different kinds of robots around, and get to see what they do or the different things they can do. So as for the competition that I'm doing, I learned a lot about the other teams and get to know more about how their robots operate, and also how we can improve on the robot.
So for this one, for this particular one, for this RoboCup competition, we always get the students, a lot of students. And these students, we take them from year one. Their project, or the final year project, or their internship is actually year 3, only one semester. So from year 1, we already take these students. Because the seniors teach the juniors. We just observe, guide. And every single batch that comes from RoboCup goes to work in companies for ROS. Because these guys, they already know ROS. When they come up from the competition, they are proficient in ROS. Okay? But the only thing that is more probably a better value for the companies is that they know how to work under pressure. Teamwork as well. They are very good at teamwork. Because remember, from year 1, year 2, year 3, they've been working with people from different backgrounds. And they know how to express their ideas and to share them. So we create this environment so where we nurture these potential engineers. But I think, and I really just want to close here my presentation because I could go on and on and on and on. But I think the important thing is we see that there's going to be a lack of engineers. There is already a lack of engineers in certain areas. Okay? Our robots or our robot ecosystem, especially on ROS, is small. Okay? But it has a lot of potential. And I think we, all as a community, we need to nurture this thing. And I'm also thankful that many of you take our students for internship. But when our students go for your internship, also give them projects that are valuable. Unfortunately, I have also visited companies where they ask for the student, and this student is a very good student. I was so shocked when I visit there, and the student told me, my only job is just to key data into the Excel file. You want to continue doing engineering? Probably the guy is going to think twice. Because unfortunately, that's the experience that he encountered, right? So what I'm trying to say is, when these young engineers come to you, it's also your responsibility to maintain them in the game. Yeah, they might jump to another company, but hey, we all winning here, okay? Thank you everybody for your time, and thank you for your support to this young generation. Thank you so much.